Today we are going to discuss what if two groups are isomorphic. What can you say about the automorphisms of them? That means if you have two groups G and G and H are isomorphic, then what can you say about the automorphism of G and automorphism of H? So basically these things today we are going to discuss that yeah, if you take G and H to be uh, to be group, okay, just 1 second, group, and we have given that G is isomorphic to H, that we have given. So isomorphic, what do you mean by isomorphic? So if I have a function from G to H, if I have a function f from G to H, which is homomorphism 1 1 plus on 2, then we say f is a isomorphism and G is isomorphic to H. Isomorphic means they have same in characters. They might have seen different, but they are all the internal properties of them are actually equal. Okay, so this is the isomorphism. So okay, let f be if we have f and f is an isomorphism, G is isomorphic to H. This has been given. Okay, given to us. This is given to us. What can you say about what can you say about automorphism of G and automorphism of H? Are they isomorphic? Think about it first, and otherwise I am doing. So the answer is yes, they are isomorphic, and I will define a map and I will show that these two are isomorphic. So okay, let's try to observe. Okay, define what. Okay, before that, what is automorphism? Let's define automorphism. Automorphism of G, which is actually all those G. I am taking G as a function, not an element of G. Okay, I am taking G as a function. G such that G to G is homomorphism, bijective homomorphism. That means 1 1 plus on 2. Okay, and automorphism of H, which is actually all those H I am taking, H and G I am taking as a function, right? H to H, homomorphism 1 1 plus on 2. Okay, so okay, I will define another map. I am defining another map. Define another map this is called a capital phi from automorphism of G to automorphism of H. How I will define? I will automorphism. I will define. Okay, what happened? Yeah, I will define phi at any, let's say sigma is an element of automorphism of Z. Okay, this goes to f sigma f inverse. This is I am defining like that. Okay, f of sigma, and sigma is an element of automorphism of Z. Okay, what happening? Yeah, okay, sigma is an element of automorphism of G. That means sigma is a map. That means sigma is a map from G to G, which is homomorphism plus bijective. Okay. So can you see this actually, if these things, if sigma F inverse is lying on automorphism of G, automorphism of H, can you see? If you can see, then you can proceed, and otherwise you can think. I'm giving a little hint what actually happening here. I'm defining in a map in such a way that if sigma F inverse, this will lie in the automorphism of G, and this map is an well defined map. This phi map is an well defined map. How will you show? See, F is a map from observe. You try to observe those things. Now I am going to write. Observe yourself. Observe yourself, because this thing you have to observe, otherwise you cannot learn mathematics. So the point is that the first point, if F is a homomorphism, F is an isomorphism, that F inverse is also is an isomorphism. If F is an isomorphism, this implies F inverse is also. Okay, these things you have to, because isomorphism is homomorphism plus bijective, and F inverse, if F is a bijective, then F inverse is also bijective. Is it clear? And F inverse is also isomorphism. You have to show, you have to show that F inverse is also be a homomorphism, right? So first this thing, and second, try to show composition of two homomorphism is again a homomorphism. Okay, these two things you observe yourself. If you don't get, you just write the comment. I will make a precise video based on this two. So the point is that composition of two homomorphism, again homomorphism. So can you see that if sigma F inverse is if sigma F inverse, if you get these two, then you will definitely get why this is lying inside automorphism of H, and why this map is actually, this phi map is actually well defined. So automorphism of H and automorphism of B. Okay, let's just take overview over here. So what do we have? F sigma F inverse. F sigma F inverse. Actually, F be a map from G to H. Then F inverse is a map from F inverse. Why F inverse H to G, right? So if you look at this, F inverse will put it up over G. That means F sigma and some element of G here. What is sigma? Sigma is an automorphism of H, G to automorphism of H, right? So whole sigma will put it up to H map, put it up to automorphism of H. Okay, F sigma it will definitely lie the automorphism of H. What is automorphism of H? It's all those function H such that H to H is an bijective homomorphism, and the entire F, if you write this, then it will be a member of H, and if you operate F over here G, it will definitely rise to H. So this means that the entire quantity is lying on automorphism of H, right? And the map is also well defined. That means phi is a map. Did you get why it is happening? Why I am defining this map? Actually, F sigma F inverse will lie to H to G, and sigma will see H to G. Sigma will leave you G to sigma is G to G, and F will G to yeah, sigma will automorphism V, automorphism actually H, and F will F, oh, sorry, yeah. So actually, yeah, yeah, G to G, and G will leave you to H. That means the whole map is from H to H. Okay, and this map is, since F inverse is an also, that means the composition of linear homomorphism, it will also be a homomorphism, and these are all are uh, bijective. Why this is, you will you try this those two and you will get, okay, the whole entire map psi is from H to H. What are you getting? H to H. Okay, so this is an overview from why F inverse. This map is might seem very difficult or something, but you will get, okay, why actually this map is well defined. So did you get? Now I am defining what we have actually, eventually what we have. If sorry if not if phi is a map out of G to out of H such that phi of sigma, this gives you F sigma F inverse, right? And what we are leaving, you just show psi is, this phi is actually homomorphism plus 1 1 plus on 2. Try yourself first, otherwise I'm doing what actually it says. So let's try to homomorphism, whether it is a homomorphism or not. Homomorphism, is it a homomorphism? Yeah, of course. If you can take two sigma 1 sigma 2 are member of sigma 1, sigma 2 are two member of automorphism of G. Okay, now operate phi sigma 1 sigma 2. This, what will you get? F sigma 1 sigma 2 F inverse. Is not it? This actually gives F sigma 1 F inverse. You can take, and you can also take F sigma F inverse, because these two will give you an identity. So I can definitely put it up over here, right? So you can take this to be separate, right? And this is actually nothing but phi of sigma 1, and this is actually phi of sigma 2, right? So this phi, okay, did you get? This phi is an homomorphism. So is it 1 1? Is not it? It is quite obvious to be 1 1. Can you see why these two are this map, this phi is 1 1 1 1. First try yourself, otherwise try yourself. If you don't get, then see the video. Phi is 1 1. Why phi is 1 1? You take two elements and their images, if their two elements are same, two images are same, then you have to show that elements are actually precisely same. Okay, this is the definition of 1 1, and otherwise you can use the contrapositive option, but I am using the traditional definition of 1 1ness. So I will take let's sigma 1 sigma 2 are two member of automorphism of G, and you are assuming phi of sigma 1, this is actually phi of sigma 2, right? So what you will get? You will get F sigma 1 F inverse is actually nothing but F sigma 2 F inverse, right? You will get operate F inverse in this side. You can take it F over here, and F is also over here. These two will give us the identity. That means F sigma 1 is actually F sigma 2. Okay, because these two are, if you operate inverse with that same function, then you will definitely get it identity. I am assuming you are already good enough to understood. So if now operate f inverse over here, right? F inverse f and f inverse, this will also give you identity. That means sigma 1 is actually gives you sigma 2. So this map psi is 1 1. Now we are only lefting out with onto portion. So onto is also very easy. You just need to put the definition of onto. What do you mean by an onto map? Ontoness. Ontoness means if you have, this is automorphism of H and this is automorphism of G, auto of H and it is auto of G. If you put any element over here, you should be able to give me any element over here. That means that this image, that means every element of codomain has an pre-image in domain. Okay, so let H be any arbitrary member of automorphism of G, automorphism of H, right? You should be able to give me an element phi over there, here. This will give us H. What can you take? You can take, I'm taking it to be let H dash, right? F of H dash. Take, that means H dash, when H is here element, you should be able to give me an element H dash over here, such that under the map phi it will give me H. Take H dash to be F inverse H F. Of course this will work very nicely. How? Why? If you take phi, H dash means F inverse HF. Okay, you will get what you will get. You will get F inverse H F inverse. I am just putting to here, and F and F, this phi map is already defined like that. Phi map is already defined, right? Phi map, what is phi map? Phi map is like that. Okay, so just I am using the definition of how I have defined the map phi. So these two will give us identity, and we are only lefting out with this map H. So we are done. So every element H inside the automorphism of H, you will definitely get an pre-image inside the automorphism of G, right? This if you take this times of H, then you just take the F inverse HF, you will get. Okay, so now phi is onto also. So what is the conclusion now? Phi is 1 1 onto and homomorphism. That means phi is an isomorphism. Did you get? Now, so if phi is an isomorphism, then we can definitely say automorphism of H, automorphism of G is actually isomorphic to automorphism of H. So this is proved. If you don't get any step, you just comment it below. I will definitely try to make it more precise to you. Okay, so okay, we'll meet okay, we'll meet some. If I get free time, then I will definitely make a video on today or tomorrow. Otherwise, whenever I will get free time, I will definitely upload a video, like interesting video, right? So that much is for today. So I am leaving this session. So thank you everyone.